Integration using trig identities. Let me start with one. Don't want to do that. Let me start with a couple that you can do that don't do this. You don't have to write these down, just reminding you. So you can do that. Well, the integral of sine is negative cos. And then I have to divide by the derivative of that, which is 3. And you can do sine 3x cos 3x, because this is related to the derivative of that. So you can use substitution. I'm not going to bother doing it. Right? You can use substitution. In fact, you can do that for sine to some power, because this is derivative of that. All of that you can do with substitution. But this you can't do. Because if I'm going to use substitution, I would need a cos here to get the derivative. But there's no cos, it's just sine squared. So how am I going to integrate this?
Trig identity.
Which trig identity am I going to use?
Sine A plus B. Right.
Is that going to help?
Squared.
The 1 minus.
It's got a squared in it. It actually is in the dot point.
1 minus cos squared.
Not cos squared.
1 minus 3. Half cos 1 minus b.
I'm going to reduce the power. Remember I showed you power reduction? Long ago,
Yeah.
a couple of weeks ago. I can turn a sine squared into something without a squared. Remember doing that? This is why. Because I can't integrate this with a squared in it, but I can integrate this. You can put the half inside, doesn't really matter. I just did that because it means I can go half. The integral of 1 is x. Integral of cos is sine over 2, no, over 6. Are you comfortable with this step? Because you should be. This is the new bit. All I'm doing is replacing a sine square with something without a square, using power reduction. If you wanted, you could go half x minus 1/12 sine 6x, if that's neater. Either way. Let me give you another one. I'll keep it simple. Go. No, half of 4 is 2. Integral of cos 2x minus 1
Plus.
minus. No, plus. Well spotted. So that's going to be divided by 2, so I'm going to get negative sine, no, positive sine. Did I? Integral of cos is sine, yes, okay. Sine 2x plus 2x plus constant. Integral of 5 plus 3 tan squared x dx. Have a look at your formula sheet. Can you see an integral for tan squared anywhere on there? On your calculus page? No integral of tan squared. Is there something I can use in my trig identities that I can turn tan squared into for which there is an integral on your formula?
Tan squared plus 1 is sec squared.
Correct, and is there an integral for sec squared?
Yeah.
Okay. So, this is 5 plus 3, 1 plus tan squared is sec squared,
1 plus tan squared is sec squared.
which means
Minus
sec
1.
squared minus 1. Yeah. Sec squared x minus 1 dx. Which is the integral of 5 plus, 3 sec squared, 5 minus 3. Which is 3, what's the integral of sec squared? Plus 2x plus constant. So where did this weird integral come from? The integral of sec squared is tan. We have done this once before, but I will do it again. Get a different colour at least. Oh, let me write it differently, hold on. How am I going to get dy dx? I'm going to work out the derivative of tan.
Sine cos.
That's sine x on cos x. Remember then, give people a little bit longer to think. Which is u on v. I'm going to want that space. U is sine x. V is cos x. U dashed is cos x. V dashed is negative sine x. So dy dx is v u dashed minus u v dashed on v squared. Remember, quotient rule. V u dashed minus u v dashed.
Is it not minus?
Sorry?
No, just ignore me.
Okay.
Yeah.
What's on top of this fraction? So what's on top? Cos squared plus sine squared? Whoops. Which is sec squared. So therefore the integral of sec squared x must be tan x. And exactly the same if I had, there's another one with cot in it. They say cot squared plus 1 is cosec squared. So you can do the same sort of thing if this had cot squared. Use a trig identity.